Hello and welcome to this Python tutorial. In the previous tutorial we took care of the first step, the convolution step, so that's one step done and now three more to go. And in today's tutorial we will take care of the second step, the pooling step. So quick reminder, this pooling step is very easy, it just consists of reducing the size of your feature maps. And how do we do that? Well, again, we take this 2x2 subtable, this blue square table that you can see here, and that we slide all over the feature map, and each time we take the maximum of the 4 cells inside this blue square. So taking the max is called max pooling, and we slide the square table with a stride of 2, not with a stride of 1 as we did previously with the feature detector that slided over the input image with a stride of 1. Here it's with a stride of 2, and therefore, since each time we take the max of a 2x2 table, well, what happens in the end is that we get a new feature map with a reduced size. And more precisely, the size of the original feature map is divided by 2 when we apply max pooling. Well, here we can see that the dimensions are 5 by 5 because we have 5 rows and 5 columns. And when we apply max pooling, we get a reduced feature map of 3 by 3. So that's actually half of the original size plus 1. But then if the size of the feature map was an even number, then its size would be divided by 2. So then we apply max pooling on each of our feature maps, and then we obtain our next layer composed of all these reduced feature maps, and that is called the pooling layer. Alright, and why do we do this? Why do we apply this max pooling step? It's because we want to reduce the number of nodes we'll get in the next step, that is the flattening step and then the full connection step. Because in these next steps, basically what we'll get is all the cells of our feature maps flattened in one huge one-dimensional vector. So if we don't reduce the size of these feature maps, well, we'll get a too large vector and then we'll get too many nodes in the fully connected layers, and therefore our model will be highly compute intensive. And we want to avoid this, so we're applying this max pooling step to reduce the size of our feature maps and therefore reduce the number of nodes in the future fully connected layers. And that way this will reduce the complexity and the time execution, but without losing the performance. Because by taking the maximum of these 2x2 subtables of the feature map, we are in some way keeping the information because we are keeping track of the parts of the image that contain the high numbers corresponding to where the feature detectors detected some specific features in the input image. So we don't lose the spatial structure information, and therefore we don't lose the performance of the model, but at the same time we manage to reduce the time complexity and we make it less compute intensive. So that's a very important step, and let's implement it right now on Spyder. So here it is, all prepared. We're gonna start by taking our classifier as usual, because again, what we're gonna do now is use a method which is still going to be the same add method. So dot here and then add. Alright, and now parenthesis. And now we're going to use a function that will complete this max pooling step. So according to you, what is going to be the name of this function? Well, very easy. You have it right here. It's max pooling 2D. So let's input that in our add method. Max pooling 2D. Alright, and then new parenthesis to input the size of, this subtable that we slide all over the feature map to take the maximum in each subtable. So the size parameter is called pool size. Here we go, and then equals, and then parenthesis, and that's where we input the size. So in the example given in this slide, as you can see, we take a size of 2x2. And this is actually what we take in general when we apply max pooling on our feature maps created after the first step. Well, most of the time we take a 2x2 because we don't want to lose the information. By taking 2x2, we keep the information and we're still being precise on where we have the high numbers in the feature maps that detect some specific features of the input image. So 2x2 is fine, and I recommend using that most of the time. So to input this 2x2 dimensions, it's very simple. We just add 2, and 2. Alright, and that's done. The max pooling step is done. We don't have any more parameters to input. Basically, adding this line will reduce the size of your feature maps and it will divide it by 2. So I'm going to select this line and execute. Here we go. Now the size of our feature maps is divided by 2. So we just reduced the complexity of our model without reducing its performance. Perfect. So second step done, 2 more to go, and we'll do the third step in the next tutorial. Until then, enjoy machine learning!